Good afternoon, everyone. We decided to give you a little bit of an extra long break there, give you a couple of more minutes to revive and get ready for the final session, Neuropreneurs. This session, again, features three speakers, and Campus Alberta Neuroscience's focus over the past few years has included more and more entrepreneurship opportunities. One such opportunity is the Seed Grant Program, wherein Campus Alberta Neuroscience provides some funding and education to help launch Alberta-based companies. In this session, we will hear from three seed grantees on their process, challenges, and most importantly, the amazing work that they are doing. And our first presenter will be Dr. Tuan McKinney. Dr. McKinney completed his BSc at the University of Alberta with a research focus on hippocampal neurophysiology, working with Dr. Clayton Dixon before completing his PhD at the University of Utah on brainwave technology and psychological assessment. He co-founded 8-Bit Cortex to adapt his research into gamifying corporate burnout risk assessments and improving workplace wellness for everyone. As the research director for Branch Out Neurological Foundation, Dr. McKinney promotes the impact of innovative brain health research and shares this insight with the community. And when not thinking about the brain, Ty can be found exploring nature, enjoying craft beer, or connecting with the growing Alberta tech ecosystem. Dr. McKinney, welcome, and the screen is yours.
Awesome, thank you so much. Let's give it a sec for my slides to pop up there and we'll get going. But yeah, thank you so much for having me join today. It's actually my pleasure to be here. 8-Bit Cortex actually received the Campus Alberta Seed Grant, and that was one of the things that helped us get off the ground in our first year. So got a lot of gratitude towards the Campus Alberta Neuroscience for that reason. And I'm excited today to share my own neuropreneurial story going from academia to industry. But I figured we would get started at the very beginning of my research career just to kind of help situate things. There we go. Yep. So the first research lab that I worked in was the Brain Rhythms Lab at the University of Alberta with Dr. Clayton Dixon. So I was working on hippocampal neurophysiology at the time, and the details of that study don't really matter so much for this talk, but what is important is that over the course of working in Dr. Dixon's lab, I really gained an appreciation for how powerful time series analytics could be. That there's so much information that's within those squiggly lines, and that if you have some creativity with your analytic strategy, you can really get a lot of insight into what the brain is doing. And then additionally, the study was also funded by Branch Out Neurological Foundation, which will pop a little bit more into my story later on. And then it was also while I was in this lab that I started to realize the problem that I would dedicate the next 10 years of my life to. So basically, when it comes to mental health assessment, the underlying technology really hasn't changed since World War II. The gold standard is still a questionnaire or an interview, and that's how we have to do pretty much all mental health diagnoses. So I'm pretty sure there's a few people in the crowd that can appreciate that there is some bias in that methodology. And when I was an undergrad, I actually had someone that was negatively impacted as a result of some of that bias. So this really resolved my motivation to do something about this. And after working for, at this point, 3 years in a neurophysiology lab, I knew that we had all this rich access to insight into what could happen to the brain through brainwaves. So I decided to pursue a career in how we could incorporate different kinds of technology into psychological assessment. And that brought me down to the University of Utah for my graduate education. So while I was, next slide, please. Yeah. At the University of Utah, I was originally accepted into a clinical neuropsychology program, meaning that I was cross-trained as both a clinical psychologist specializing in cognitive assessment, as well as a researcher using EEG methodologies. Turns out after 2 years, I found out I'm not actually a particularly good therapist, so I switched over to a purely research track. But those 2 years of being in those clinical settings, it was really informative because it helped me realize how some of my ideas on how this technology could be incorporated were ill-formed and naive, but it also opened up other ideas for how this technology or how different approaches to technology could potentially be incorporated as well. Next slide, please. So while I was in graduate school, I was still working with, as I mentioned, EEG activity, but this time coming from humans as opposed to rats. And humans have a few quirks about their data. Namely, they have individual differences, meaning we can't just assume that all humans are interchangeable. So for that reason, I had to get very creative with some of the statistics that I was using to analyze my data. And this led me towards what I think is one of the most important amounts of insight that I received over the course of my PhD. Next slide, please. Basically, most statistics that we all use are modeling straight lines. I think something like 85% or so. So all your t-tests, those are fundamentally modeling a straight line. ANOVAs, for the most part, again, are modeling a straight line. Parametric tests, straight line. Correlation regression, again, it's a straight line with a slightly more complicated formula. So when I was trying to figure out ways that I could better model my EEG data, I came across an approach to doing statistics that comes from nonlinear dynamical systems theory, which basically makes the assumption that we're working with complex systems and that they evolve through time. And the best way to understand how these systems operate is to measure them through time, that is, get time series data, and then model them as something other than a straight line. And you can be creative with what exactly that nonlinearity is. It could be as simple as adding a quadratic term, so you're modeling now a curved line. Or, as I'll show you in just a moment, we could also model the time series data as a thermostat. Next slide, please. So learning about these approaches, I published my review paper on how we could use this analytic strategy to work with data collected from smartphones towards cognitive assessment. One of the advantages of this approach to doing statistics is that it's actually really robust to noisy data. So whereas normally you don't want to have too many things going on in your data set because it can reduce your statistical power, this approach to statistics actually thrives on some degree of noisiness within the data. You can read all about it in this particular paper, but in the discussion, I had one throwaway line where I was talking about the adherence to some of these smartphone data collection protocols and how generally that they weren't very good. And the gamification could be an interesting way to improve that adherence process. So on the right-hand side there, you can see the prototype that we built for 8-bit Cortex before we actually became a company, as we were applying for the Campus Supported Neuroscience funds. Next slide, please. So up until this point, I've really been talking about what's my experiences within the laboratory have been and how they're informing my scientific ways of thinking. But in order for innovation to work, at some point it has to come outside of the lab. And it's at that point that the magic really starts to happen, where you're taking these new, interesting ideas and you're trying to pair them up with problems in the real world in order to generate solutions. So I was able to take my clinical experiences and research from my training at the University of Utah. And throughout the entirety of my graduate training, I was also serving as the research director for Branch Out Neurological Foundation, which takes a relatively innovative and entrepreneurial approach to the research that we fund. So as a result of these experiences, I felt very empowered that I could start up my own tech company, of course with the team, you can't do anything alone, and try to make a difference. And this is about the time when COVID had just started. So since I was working with older adults at the time in the lab, most of my research responsibilities basically disappeared overnight. So I couldn't be idle, so instead I decided to build a company. Next slide, please. So, and this is where we need to start thinking about how we can refine the problem that we're trying to tackle a little bit more. So mental health is obviously a very complex problem that's got lots of different angles to it. But after we started doing some business development research, we realized that the workplace is actually a really exciting opportunity to try to affect change as it relates to mental health. Mental health is really expensive, particularly when it's untreated. And employers actually face a large portion of that cost. So this is based on some data from KPMG and a couple other sources, where they found that over the course of the last couple of years, there's roughly 10% voluntary turnover in several different professional industries, meaning that these are people, they're not getting fired. They're voluntarily deciding to leave their job for one reason or another. And that all the costs associated with this add up to be about $10,000 per employee per year. So that's quite the steep number. And you might be thinking, where is all that coming from? Well, we can break that down into a few individual cost components. So the first one is absenteeism and by association presenteeism. So this is when you take a mental health sick day. So you're not actually showing up to work, but you're still being paid in some capacity. So that's a cost towards the employer. Or there's the related idea of presenteeism, where you do show up to work, but you're not at 100% capacity. So you're still having some lost productivity. If those issues don't get resolved, it can lead towards a short-term disability, where you might be out of the position for weeks, potentially months, due to a stress leave. So again, this is very costly for the company because, again, throughout that entire time, you're not actually doing the work and they're having to compensate it from other people. And then a lot of people that are on short-term disability don't actually return back to their positions. They contribute towards that 10% burnout statistic. And as a result, these positions remain unfilled, cost the companies further money. And to fill the positions costs yet more money, because it turns out that hiring people is intensive, both in terms of the money that it takes as well as the time that it takes. And ultimately, if these problems aren't managed over a longer period of time, your insurance premiums will actually start to increase as well. So that's all what's contributing towards that $10,000 cost per employee per year that every Canadian company is facing in some capacity. Next slide, please. So where this ties in with the technology that Apic Cortex has been developing is we can try to track 3 different components of burnout based on the scientific literature. Some people can debate over the labels for these, but more or less they come across as these 3 distinct concepts or constructs or factors. The first one is chronic as opposed to acute stress. As a group of neuroscientists, I feel like that's fairly intuitive. And then there's also this idea of reduced cognition, that you're trying to do your best work, but between the stress hormones and your anxiety and anything else that might be picking up, your cognitive capacity isn't 100% there. So as a result, you're not going to be able to meet your objectives and your goals quite as effectively. And then there's also this emotional component of cynical attitudes that develop as well. So these are 3 distinct but somewhat related components of burnout. And what we can do within our gamified mental wellness app is track each of those individual components and see how they fluctuate through time, and then apply those nonlinear dynamical system models to it. So next slide, please. This is an example of what some data can look like, where we have a time series of just someone's report on their stress over the course of several days. So I've got on the left-hand side, there is the model as though we were to be modeling this as a thermostat. Next slide, please. And where the magic happens is that we'll actually create a change score from one time point to the next time point, what that subsequent change is. And pragmatically what this does is it takes a regression equation and allows us to estimate what is basically a first derivative. And this allows those coefficients that we get out of the regression model to start to have a little bit more interesting meaning. Next slide, please. Critically, we can start to get out these other ideas, such as a set point and stability. So I'll talk about these briefly. So first, there's set point. Next slide. You can think about this as more or less being analogous to a mean. This is the point of stability within a complex system where the system's going to try to return to after it's being perturbed away from it. So under relatively simple systems, it's going to be mathematically equivalent to a mean, so you can kind of think about it that way. Next slide. And then you can also think about this idea of stability. So it's not just what is the point at which it's most stable, but how quickly does the system come back to that homeostatic set point when it is perturbed away. So we're able to get both those pieces of information out of that very simple equation up at the top there. And if we elaborate and add an additional terms to that formula, we can get even more nuanced characterizations of these complex phenomena. Next slide, please. So now we've got a little bit of extra time. I'm going to invite everyone to actually do a demo of our app. So I'll get everyone to scan the QR code. I recommend using Google to make an account. And then I'll just give everyone a few minutes to go through and try one of our check-ins. So that way you can see what our gamified check-in process is like. And then all that data that you would be doing, that's just being fed into our algorithms that we're using to develop a predictive burnout. And then there's also the link is in the chat as well if anyone's having any trouble with the QR code. I know sometimes that doesn't scan the easiest depending on your monitor and stuff like that. All right. Well, I'm going to keep going for the sake of staying on time. So I'll get you to advance to the next slide, please. So more or less, we're able to use this experience, this demo that you're doing as part of a gamified engagement survey service that we offer. The way that this works is we'll start by onboarding people onto our app, very much so like you're doing right now. And then there'll be a series of daily check-ins. So we'll get people to do this check-in process once a day for 7 days. And each day there will be a slight different tweak as far as exactly which data is collected. But the important thing is that we're able to get that time series data that we can use to apply those dynamical systems algorithms in order to give estimates of the burnout risk for the company and try to forecast it out. So once we collect that data, we'll summarize everything into a report, and then we'll have a follow-up workshop with the company in order to illustrate exactly what the results are, what it means for them, and how they can use that data to be more strategic in their burnout management moving forward. And we're excited to be working with insurance providers to find ways that we can give access to employee assistance programs and other insurance benefits more readily. Next slide, please. And then based on the data that's collected, we actually present personalized content within the app itself. So we really try to take an approach of neurodiversity with all the content that we have within our app. So this is acknowledging that there's trade-offs. There's not necessarily one brain is better than the other, but there are going to be certain scenarios where certain brains are going to be strategic, and there's going to be some trade-offs associated with it. So using ADHD as an example of this, we can talk about how people with ADHD often have they seek a lot of dopamine in their environment. So they're seeking out rewards, bigger risk, big reward. They're really seeking the dopamine. So this can make them beneficial in certain career trajectories like entrepreneurship, but it might make them a little less effective in other career trajectories like law, where you don't want to be quite as risk-taking. People with ADHD often tend to be stress adapted. So they actually perform really well in high stress environments where there's a really fast pace. But the flip side is they might not perform as well if they're in a very calm environment where there isn't that same degree of stress. And then finally, there's the cognitive symptoms that are associated with ADHD. We probably know that people with ADHD sometimes struggle with focused attention, but the trade-off is that they actually have much more efficient task switching. So humans can't really multitask, but to the extent that we can, ADHD people are slightly better at doing it. So again, it's all about trying to illustrate to people what their strengths are so they can leverage those and find ways to supplement their weaknesses. Next slide, please. So then what we do is we take all the data, we plot into a dashboard like this so we can start to illustrate it and generate up that report. Next slide, please. And then this is just a quick quote we had from our first pilot customer, is that being able to extract that information and have a deeper understanding of how different personality profiles look like both their type and level of burnout was very helpful. And this company was actually able to use the service that we provided to inform their next hiring decision. So overall, we're really excited with the progress that we've been able to make from transitioning from ideas from an academic environment into real-world settings. And again, thank you very much at Campus Sport and Neuroscience for that seed grant to help really kickstart us off. And on that note, I'll take questions and let you finish your demos.
Thank you, Ty. Thank you. This is amazing. It's just another example of how everything in life is going to be mediated through our phones. That's so cool. We got time for one question here. This is Ty, super cool work. Regarding these models, is there any fear of over-optimization to an individual's data set?
Yes, that's a really good question. So the models that I presented can be applied to individual subjects, which makes them really useful. But that does present the possibility of overfitting. So really what you want to do is have a good a cross-validation approach. And that way you can take the parameters that are generated from one individual and see how they work for another person. There's going to be some degree of individual differences present, but yeah, the solution to that is really making sure that you cross-validate your models and your data set. So train it up on 70% and then test it on the remaining 30, or some combination like that.
Okay, thank you very much. We will see you in at the end of this session for the panel discussion. Thank you very much, Ty.
Awesome, thank you.
Our next presenter rather, is Dr. Tuan Trang. Dr. Trang is a professor at the University of Calgary, director of the Alberta Pain Research Network, and lead of the Spinal Cord, Nerve Injury, and Pain Neuro team. His team is committed to unlocking the causes of chronic pain at the level of genes, cells, and circuits, and he is also the CEO and co-founder of AphioTX, which is developing safe and effective treatments for opioid use disorder and dependence. Dr. Trang, great to have you with us.
Great, thank you, and sorry about the technical problems. Speaking of stress levels,
only people who know the technical problems were behind the scenes.
Oh, so awesome! Because I got booted out, my camera didn't work. But anyways, I'd like to start by thanking Campus Alberta Neuroscience for the opportunity to share work from our team and for the tremendous support over the years. CAN has also been instrumental in helping us build the Alberta Pain Research Network, or APRN, and this network was created to bring together researchers, clinicians, caretakers, and people with lived experience to revitalize how pain is treated and researched in Alberta. And so, slides, please. Oh, great. Next slide. So our team is working to understand the causes of chronic pain and how to better treat this condition. An area of focus is on improving the safety of opioid medications. And so this presentation, I have to say, is much more than the science. It is also about the many talented people who you see here as the current members of our team who have contributed to the scientific discoveries, our clinical team who care for people in the community, and the partnerships that we have formed that have been key to moving this potential treatment forward. So everyone has played a really important role in this journey, and so it is these people that are the key to success. Next slide, please. So we know opioids are important medications for managing a variety of pain conditions. They act on the central and peripheral nervous system, and what they do is they suppress how pain information is communicated, and that's why it produces pain relief. Their long-term use, however, is associated with many side effects. People become dependent on it, and one of the most dangerous aspects of opioids is that at higher doses or more potent opioids, they act on centers of the brain that control breathing. And what they do there is they inhibit breathing, and in doing so, it can lead to death because it stops the individual from breathing. Next slide, please. So because of the widespread use of opioids and tainted sources of opioids, it has led to increase in number of opioid-related deaths. And over the past 17 years, there's been about a 600% increase in the number of those deaths. And during the pandemic, the situation actually got a lot worse. And many of the people who overdose were struggling with opioid use. In fact, it's estimated that about 26 million people worldwide struggle with opioid use disorder. Next slide, please. One of the major problems contributing to the opioid crisis is that people using opioids for the long term develop a dependence on the drug. And so when they try to stop or reduce their opioid use, they experience withdrawal. And so what happens is that this repeated opioid use causes the body to adapt. And so you can think of it as a new set point, so to speak. And so when they stop the opioid, when the opioids are not on board, These changes are unmasked and they present as the debilitating symptoms of withdrawal. And to relieve these symptoms, people will continue to use opioids. In fact, withdrawal is the main reason it is difficult for people to get off of opioids. And so treatments that reduce these symptoms can help break the cycle of opioid use. And it's important to note that withdrawal can affect all people on long-term opioid use, on long-term opioids, not just those that misuse or abuse opioids. So for example, people can be using opioids as prescribed and can still experience withdrawal when they stop their opioid pain treatment. Next slide, please. And what can happen for some people who misuse or abuse opioids is that initially they may take opioids because it makes them feel better, so euphoric. And then over time, that effect kind of is blunted. And when they try to stop, they experience withdrawal. And if they are able to overcome the withdrawal, there may be a circumstance in life, a life stressor, that then causes them to relapse. And so then they begin that cycle. Next slide, please. And so we hear from people in the community. They reach out to us sometimes. And one individual said that they were 62 years old and they tried to stop their opioid medication, but the withdrawal is awful. They have nothing to lose. They can't live this way anymore. And it's like the new cancer. Another individual said they've tried everything, every program. Nothing has been successful. And so, and they say that the physical pain and the opioid withdrawal just kills any attempt at rehabilitation. And so we hear these individuals, it's heartbreaking and it motivates us to try and find a solution. Next slide, please. Unfortunately, there aren't a lot of options. The most common approach is that people are put on opioid agonist therapy. And so they're, in essence, really put on another opioid to treat their opioid use disorder. Non-opioid options such as lofexidine or clonidine affect the autonomic system. And so they also have really serious side effects. And so it's not surprising that less than 30% of people actually achieve opioid abstinence. And in fact, relapse on opioid medication is about 90%. So it's very, very high. Next slide, please. So recognizing this need and a lack of understanding of what really contributes to opioid withdrawal, Nicole, very, very talented PhD student at the time, was looking at, well, what are the underlying mechanisms? And what she identified was that there was a really important class of immune cells called microglia that reside only in the brain and the spinal cord. And what happens is that when in our preclinical models, when animals go through withdrawal, that there's a hyperactivity, or there is an activation of a very specific channel known as pannexin-1 channels. And those channels are important for those immune cells to communicate with other cells. And so she identified that they were releasing a signaling molecule known as ATP, and that then contributed to the hyperexcitability that underlied some of the withdrawal behaviors that we saw. And so she used a bunch of sophisticated tools to block that channel, to impair its function, and all of them that, when they block that function of pannexin-1, produce a alleviation of opioid withdrawal. Next slide, please. And one of the most exciting observations that she made was when she treated animals with mefloquine or probenecid, and those are non-selective or broad-spectrum pannexin-1 blockers. So they block that particular channel that was really important for those immune cells to function. So mefloquine is an anti-malarial drug. Probenecid is an anti-gout medication, and what you're looking at in the right is the withdrawal score. So in rats that we need dependent on opioids, when you inject naloxone, they display these withdrawal symptoms, and you can measure them, those behaviors, and you can get a cumulative score. So the higher the score, the more intense the withdrawal. And so MS is morphine. And when we treat the animals with either mefloquine or probenecid, we could blunt or alleviate those withdrawal. And so we decided to run with actually probenecid because of its impressive safety profile. Mefloquine has, other side effects that we thought probably made it not as an ideal candidate to proceed in terms of translating as a potential therapy for opioid withdrawal. Next slide, please. And so the advantage to being able to use a medication that's already FDA or Health Canada approved is that we can jump ahead in this timeline of being able to translate it. So we were able to actually, with probenecid, jump to a phase 2A clinical trial. So probenecid, we were really excited about it because it's a non-opioid, there's no addiction liability, has a very impressive safety profile. So recently we received ethics approval, Health Canada approval to run our phase 2A trial, and we should be recruiting very, very soon. So the idea is that because it's got this known safety in people, we can move to 2A and then eventually 2B and then a phase 3. So the idea is that probenecid might be a first-in-class treatment, non-opioid treatment for opioid withdrawal. Can you click the button, please? And so as part of this, we also have a second generation compound. So what we did was we looked at the structure of probenecid and we tweaked its structure to make it better. And so these are new chemical entities that are actually also non-opioids, no liability potential, but they're even more powerful than probenecid. But we have to characterize it so they're further back in drug development. So, but ideally, this new chemical entity will become the best in class after we are able to help people with the first in class probenecid treatment. Next, please. And so when I mention important people, we have a really impressive clinical team. Dr. Lori Montgomery is the clinical lead for our trial. Sam Parmenter is PharmD. We have a geneticist, Chad. Tammy is our nurse. Janet is our clinical trialist. So really just excellent clinical trials team. Next slide, please. And so how do we envision a probenecid or a pannexin-1 targeted treatment? How would it work? Well, we think that it could be a medication that could provide immediate relief from opioid withdrawal and reduce risk of relapse. It may be used in combination with opioid tapering, that is a systematic reduction in the opioid use for an individual, or in combination with an opioid agonist therapy. And so the idea is that it would shorten the time needed for treatment, reduce opioid dose, and so in doing so, decrease health risks associated with the lower dose and ideally lower health care costs associated with opioid addiction. Next slide, please. And so what we've done is we've partnered, we've made key partnerships with Castex Ventures, and what they bring is considerable strategic and operational expertise. And so together with Castex Ventures, we formed a startup company known as Affiotics, which is a pharmaceutical startup based in Calgary. Next slide, please. And so this is our team. We have an excellent scientific team. Roger, Darren, our scientists, Lawrence, and Janet, our clinical developments personnel, and they're part of Castex. And Castex also has Mark and Gord and Christian and Ryan, and they bring considerable business background and operations background, and has really accelerated the rate in which we've been able to advance with the company and secure key patents. Next slide, please. And so what we've been able to do in terms of patents, which has been really important for advancing this therapy and the startup company, is first, we were able to secure patents for probenecid and its use for opioid withdrawal in the US and Australia, and we're waiting to hear back from Canada, China, and Hong Kong. We've also proceeded with patent filings with the two new chemical entities, and so that will be also a long process, and we're in the midst of doing that as well. Next slide, please. And so we've built considerable momentum, and so our partnership with Castex, we've been able to secure donor funds, and we have some other opportunities in the background that we are navigating right now. And also Campus Alberta was one of the earliest believers and supporters of us as well. So thank you for that. And it's been instrumental in helping us develop the new chemical entities that's formed a really important branch of our startup company. And as I mentioned, we've secured key patents. And also, when we were right out of the gates, we decided to join TNT Startup Competition, and we placed in the top 10 right out of the gates. Next slide, please. And so an aspect that we're really working on is that we have built important connections with the community. And we held a successful community event on the opioid crisis, and we've engaged key organizations who have been very supportive and expressed a desperate need in terms of better treatments. And we really do value input from these organizations as we begin to hear what is most important for them, what is needed at the grassroots levels. And so we'll be continuing to foster and expand these community relationships. Next slide, please. And at the end of the day, our goal is to develop a potential therapy to help individuals, their families and communities overcome their struggles with opioid use. And we're hoping that the potential therapy that we have is but one piece of the puzzle. That is, it will help them overcome some of the physical sort of barriers associated with opioid withdrawal, the medical sort of related issues, to position them in a better sort of spot to be able to engage in other supports that they may need on their road to recovery. Thank you so much.
Thank you, Dr. Trang. That's extraordinary, an extraordinary adventure. And this is a question that we could probably apply to the whole panel, but I'll ask you, what's the biggest obstacle to taking a new treatment and bringing it to market, sort of getting it to market and building the business?
Funding. So a lot of times there's a lot of really important scientific discoveries that are published in very high profile journals. And many times it's just kind of left there because there's this whole big divide between scientific discovery and translation in the clinic. And so a lot of times also is because we don't have the resources to be able to run the clinical trials, to be able to develop the drug so that it is safe and we're able to test, in people, right? And so that pipeline is long and requires a lot of investment. And so at some point or another, that gap between discovery and translation is quite large. And then there's a long process afterwards as well.
There's a question here in the question box. Is there a challenge creating a new drug when big pharma is throwing their weight around?
Yes. So we can't compete directly with big pharma, but we do. I think as academics, we have an excellent research program. So we often are on the forefront of knowledge and identifying targets and everything. And so this is where academics, as myself and others, we've become more aware of the importance of being able to patent and protect our discovery, to advance it as far as we can. But pharma isn't necessarily our enemy per se. At some point in time, for us to be able to move forward, we will need to probably partner with them because they have the infrastructure. They have the capacity to mass produce. And so ultimately the goal is to be able to help as many people as we can to develop a potential therapy as quickly as we can and to make it as affordable as we can. And as a researcher, we don't have those capacities, but we do have a lot of really smart people, a lot of talent to be able to understand certain diseases and develop new drug targets, but we will eventually need to partner with pharma. And so I think it's more a partnership as opposed to sort of an adversarial relationship.
Good to hear. Okay, well, thank you again, and we'll see you in a few minutes with the whole panel. But now we'll come to the final presenter in our day-long session: Successes in Neuroscience, Healthy Brains Across the Lifespan. No pressure on Dr. Wee Yong. Dr. Wee Yong is a professor at the University of Calgary and director of the Alberta Multiple Sclerosis Network. He is an elected fellow of both the Canadian Academy of Health Sciences and the Royal Society of Canada. And in 2017, he received the Alan Taylor International Prize in Medicine for transformational discoveries in multiple sclerosis. Dr. Yong, it's great to see you. I'll let you take over from here. Thank you.
Thank you, Alan. And thank you all for your attendance. Thank you, Campus Alberta Neuroscience, for organizing this. May I have my first slide, please? Okay, great. So I thought today I'll tell you about two sagas. I call them sagas because they are long, continuing journeys with lots of challenges, pitfalls, but also a lot of excitement as well. So I'm going to tell you two different approaches because they teach us different things about bringing or attempting to bring something to market. Next slide, please. So for the first part, I'm going to tell you about our work in trying to harness the power of nature, basically trying to extract from flowers compounds that could be neuroprotective for people living with multiple sclerosis and also other neurological conditions. And in the second part, I'm going to tell you about our attempt to generate unique composition drugs for repair in multiple sclerosis. Next slide, please. So two short stories, both focusing on multiple sclerosis, but applicable, we think, quite generally. MS is a condition that affects over 100,000 Canadians, 2.8 million, I'm sorry, that's a typo, 2.8 million people worldwide. Current medications reduce the pro-inflammatory immune activity and relapses, but they do not quite protect the neurons in the brain from neurodegeneration. And one of the insults that have become topical and important in neural injury in MS is iron-mediated injury. So that's the first part. And also medications do not help improve the repair potential of the brain, the repair of myelin specifically, and I'll touch on that in the second part. Next, please. So iron accumulates in the brain of people with MS. It accumulates early, and where it accumulates is correspondent with areas of injury. And this work actually comes to us from Alan Willman's group at the University of Alberta. And using MRI, he has been able to document iron deposition in the brain. And he depicts it in the third panel, iron in MS brain, and where iron accumulates. Here he shows loss of myelin detected through MRI signatures, but there's also underlying loss of neurons and axons as well. Next slide, please. In tissue culture, if one puts iron onto nerve cells, neurons in this particular case, one can show that iron is very detrimental. So within 24 hours, you see that pretty much most of the neurons have died off and are no longer available for you to visualize. Next slide, please. So can iron neurotoxicity be protected by nature? Can we tap into the secrets of nature? And specifically, in thinking about how flowers, for instance, continue to remain vibrant despite the very harsh conditions that are out there, the intense sun. And for me, growing up in Malaysia, where hibiscus is quite common and where the sun is so intense, and yet these flowers remain really quite spectacular. Can one tap into hibiscus extracts in order to think about protecting against iron neurotoxicity? And along this journey, we formed a company called Entobio, led by Ling Tang, CEO, Aldo Buccarelli, scientific officer, and myself as the research person in the lab. And part of our funding was supported by Campus Alberta Neuroscience. Next slide, please. So here's hibiscus and the subspecies specifically that we work with, Sapdarifa and I'm going to call it HS. And we've been able to extract the extract that you see there for our work. Next slide, please. And here I'm going to show you neurons in culture that are going to be destroyed by iron, and the potency and the power of the HS hibiscus extract to protect against this. In all cases, the neurons are labeled in red, and we have put a dye into the culture medium that is going to be taken up by cells when their membrane becomes compromised, where eventually they will go on to die off. And I'm going to hope that this video works. Can I have the control? And it's actually should be longer than that, but does not matter. But one sees that over this period of imaging, a few neurons turn green, which is what we expect from neurons that are in tissue culture. And then these are going to be exposed to iron, the middle panel place. And one sees that over this period of time, most of the cells are compromised. And like I said, eventually they will drop out of solution. And then to the right, we are going to expose this to iron toxicity, but now in the context of presence of HS. And one sees that the toxicity of iron is quite completely abrogated. Next slide, please. So we have gone on to do a lot of work in this. We've published on the data. We've shown the consistency of being able to extract the neuroprotective extracts from different batches of HS. We have gone on to test this in a mouse model of MS called EAE, in which EAE-afflicted animals treated with a vehicle control are somewhat paralyzed during the experiment. And when these animals have been treated with HS, there is minimal disability, and the neuroprotection can be ascertained by doing histology of the spinal cord, and one sees that the myelin loss, the axonal loss caused by the EAE disease process is attenuated in animals that are treated with HS. Next slide, please. So, some of the highlights, really, really very potent, very impressive neuroprotective series of extracts, more potent than the MS medications that are available to us that are purported to be able to protect nerve cells against injury. These extracts can be consistently extracted. They protect not only against iron-mediated toxicity, but also toxicity mediated by A-beta, exposure to neurons relevant to Alzheimer's disease, or exposure to rotenone, a mitochondrial poison relevant to Parkinson's disease. HS is very, very protective and very, very impressive. We have published on this work. However, there's a lack of investment in undefined natural products. And also, it is too easily copied, so says the community out there. Having said that, though, we have extracted very particular mixture that cannot be matched by available claim hibiscus extracts that actually one can buy for purported treatment of hypertension. What we have cannot be reproduced by those that are out there. Even that said, because we currently have an undefined preparation, there is lack of interest. Nonetheless, we continue on this saga, trying to nail down on as much as we can. We think we are down to 0.01% of the extract, but even then, we are dealing with a very complicated natural product. Nature surrenders its power and secrets very reluctantly, but we continue on. Next slide, please. In Saga 2, we're trying to promote the repair of myelin, repair remyelination, and you see the demyelinated state where the myelin is lost, and remyelination where the myelin is put back on. And our approach is to neutralize inhibitors of oligodendrocytes that are needed for myelin formation in MS lesions. It turns out that when these lesions form in the brain and spinal cord of people with MS, there are attempts at repair, but that attempt is met with a lot of inhibitors, a very hostile microenvironment in the brain and spinal cord, and we are trying to neutralize those inhibitors. Next slide, please. One set of inhibitors that we have followed for some time are the CSPGs, chondroitin sulfate proteoglycans, and this is just an example of work showing that these oligodendrocytes in control situation grow very well in tissue culture, but when they encounter CSPGs that are laid down in lesion, they don't do well. Next slide, please. So we have sought then to disrupt the biosynthesis of CSPGs because these are elevated as a result of the injury. So we have a window of opportunity to disrupt their synthesis, and through some complex biochemistry and the collaboration of my partner, Professor C.C. Ling, a chemist at the University of Calgary. Next slide, please. We have learned how to, next slide, to inhibit them. And we have a series of furosemines, difurosemines, some of which we have described in the literature. Next slide, please. And this just shows you an example of difurosemine, one of the compounds that we work with, again, using the EAE model, where the control mice have gained a lot of disability as a result of the disease process. And when treatment is initiated in the period labeled in green, we attenuate subsequent disability. Next slide, please. And we have gone on as well to look at the reformation of myelin. And one sees that in animals treated with difurosemine, you have a lot of those green profiles within the spinal cord, suggestive of, indicative of remyelination. Next slide, please. So here's a summary of these inhibitors in lesions. Across neurological conditions, I would say the CSPGs have all of these inhibitory activities of inhibiting axonal regeneration, preventing repopulation by stem cells, preventing remyelination, and also promoting neuroinflammation as well. And our compounds have promise in reducing inflammation and increasing CNS repair. Next slide, please. So before I finish, I'll just mention that these are unique composition, meaning that they are novel composition material. We have patent applications that are pending, and we are beginning to get interest, and now actually talking to a company in the US on a potential licensing agreement. We'll see where it goes, but anyway, that is the tale of my two sagas. Thank you.
Thank you, Dr. Yong. Not one but two sagas. I love it, and and wonderful little research avenues. There's a couple of great questions, and the first one from Svenja Espenon is I think perfect. What inspired or prompted you to look into HS for the treatment of multiple sclerosis? Are there other flowers that you were exploring for MS or other diseases? Because it seems like linking hibiscus to MS is quite a jump.
It's really tapping into nature. It's really thinking about flowers and whatever that's there. In the early days, working with Aldo Bruccorelli, we had actually looked at a number of different flowers. Most of them we were able to capture protective factors on. We ran with HS because of my history of Malaysia and thinking about HS, hibiscus, and because the extracts were very, very impressive.
And another question, then we could start bringing the rest of the panelists in. Is there a process for removing excess iron from the brain, seeing as how HS only protects from the higher iron concentration?
That's a great question. It turns out that iron is needed in the brain. Iron is actually required by oligodendrocytes to make myelin. Many of the enzymes needed to make myelin use iron as a cofactor. And similarly, iron is needed by a number of other enzymes needed for mitochondrial respiration. So we cannot really remove iron. We should not be chelating out iron. There are iron chelators. They don't get into the central nervous system very well, or the newer generation do a much better job. But we don't think that should be the approach a chronic process like MS. Maybe in stroke, when you want to remove the excess iron that has been deposited as a result of the bleed, maybe for short periods of time, but we don't really want to do that. What we want is actually to neutralize the consequence of iron, and that's where the extracts are unique in that regard. That said, because they are so undefined at this point, that's where you lose the audience when you begin talking to them.
Okay, well, thank you. Let's bring Dr. McKinney and Dr. Trang back into the conversation here. When we left Dr. Trang, he was telling us about some of the obstacles and partnerships that were part of the success and challenge of starting his company. I'm be curious to hear from both Ty and Wee about obstacles that you faced in your particular journeys. Ty, do you want to tell us about some of the biggest mountains you had to climb?
Yeah, no, I think honestly the biggest mountain that we've had to climb is our go-to-market strategy. Like, it's one thing to have a solution, but it's another thing to have a vector to get your solution in the hands of people that need it in a way that's scalable. And that's one of the things that I don't think I appreciate when I started my entrepreneurship journey, how valuable having a network to do that is, or some mechanism for that is. And still something that we're ongoing trying to tackle. Of course, that's going to be different depending on like what kind of company you're forming. Whereas, like, since we're going directly for providing a service, it's more relevant for us than I think perhaps for the other speakers.
All right, Dr. Yong, what are some of your commercialization obstacles?
For the flower extracts, is the undefined nature of the flower extract. We had actually contemplated at one point to just put the the extract out there in the market, but we also knew that our extract could not be reproduced by other extracts that are out there, flower extracts, and that we could be, and that other companies could easily put their claim hibiscus extract, even though we know that if we tested them, they were not, did not have the properties that we have. So we chose not to go that route of putting out an undefined extract for fear of having a lot of copycats come into the market and actually just having people take them without any benefit and may even cause harm. So so that is our main obstacle. We don't know what we're dealing with, and we're hoping that as we move further towards refinement, that some solutions may come up. With regards to the unique composition material, there are also challenges as well. Challenges in terms of, have you tested this? Have you tested that? And we are a small research academic lab at the University of Calgary. So there are only so many things that we can do. Nonetheless, though, there is increasing interest, so we'll see where that goes.
Okay. Question just popped up here. Oh, that was Svenja just put up the question I was about to ask. So I'll go with that one. She asks it in a very good way. What would be one piece of advice you would give yourself or other researchers and trainees starting out on the entrepreneurial journey? Tuan, do you want to start with take a stab at that one? Where
do I start? Where do I start? You know, I feel like I've made so many missteps along the way, as opposed to being able to give good advice about things. I would say that being able to secure intellectual property is really important. That was something that I would say that I was aware of, but didn't fully appreciate, because as a scientist, I was more focused on the discovery of new knowledge, the advancement of our research program. But there is a strategy to being able to protect, your discoveries as well, right? And that's something that, I think a lot of researchers, universities are more aware of, because you can't publicly disclose, and it can be as fickle as someone writing a review or, presenting a poster somewhere. And so you should really, get in touch with your tech development office and ask them for advice if you really do think there's something that you'd like to move forward with. And that was something that was quite a challenge, one for Prevenice, because it was repurposing of a medication. We went through multiple rounds but we finally were able to secure patents in certain districts and stuff. But that I think is very, very key, and that was something that is very evident when we meet with potential investors or people interested in what we're doing, is that they ask, how do we protect this if we invest in your company?
And you did a fabulous job of answering the next question that came up, which was related to this, which is about protecting IP. Ty, what piece of advice can you pass on?
I think the one thing that I would pass on, particularly for this audience, is don't underestimate yourself. A lot of the things that go into running a company, particularly a tech company, have a lot of overlap with scientific research. At the end of the day, it's going to be a lot of data collection. It's going to be a lot of testing assumptions, a lot of trying to validate your hypotheses. And the process of building technology is not dissimilar from that of building a research program in a few ways. So I guess what I would say is if there's any people out there that are interested in taking the leap, you're probably more prepared than you might otherwise think. So be excited about that. And if you find a problem that you're falling in love with, then try to solve it. Make an impact.
Dr. Yong, your advice?
I would say expect a very fast-paced enterprise. While we in the academic setting can, sit back and let the data reveal itself, when you are in the context of a company, you are working on a very different timeline. So expect the need to fast forward everything. That would be, the first thing. The second thing, Tuan has already said, can't emphasize that enough. IP. We have published, well, actually, if I may say so, close to 400 papers now. It's only recently that we began thinking about, patent. So, and when we come before an audience, they're always asking, is this protected? What does it look like? What have you done with your patent application? What have you been issued? All these kinds of stuff before the science.
I'll throw this out to any of you who want to answer. Are the universities doing enough? They're the incubators for this. Do they have the right processes? Do they have sufficient energy and competence behind helping you make the leap?
Well, for me, let's I would say no. I would say our universities are trying their best, but they are short staff, understaffed, don't have enough manpower to help everything that comes their way. So I would say no.
Dr. Trang, Dr. McKinney, do you have experiences?
I'll give a slightly contrasting position. So at the University of Calgary, there's a Innovate Calgary, which started off in the life sciences. So they've got a number of programs or resources coming through there that my company's been able to find helpful and beneficial in a lot of ways. Especially if you're going to be starting a company and you're going to be bootstrapping, it's going to be a lot of trying to make do with limited resources. So I think while there's I completely agree with we that we want there to be better processes and programs in place on the university side. There is lots of resources out there available if you know where to look. So that does help out with the transition to an extent. It might not be the specific area or technicality that you're looking for, but at least it'll put you in the right direction.
Yeah, so I'll just add a little more to that. I agree with everything that's been indicated here, and we are moving towards the right direction. There is an awareness that there needs to be more support. We also worked with Innovate Calgary, and it helped us through the initial phase, and also for us to advance farther, we needed to partner with other sectors, and this is where CASX Ventures came in to help us push things forward more.
Right.
But yes, there is room for improvement, but they are aware of that, and they are moving in the right direction with some of these other programs, USEED, and these other things that we can tap into to help us, in the early phases where it's really hard, where even 10,000 make a big difference.
Right. Okay, well, we're coming up on 3:45. There's one more question up here in the window. I'm just going to remind people that in the chat window, there's lots of links to things, to individuals and things that people have been talking about. So make sure you go through the chat window and get all the links that you need coming out of this session. And the one last question I've got here is around a really good one around acquiring talent. Do you have access to the talent that you need in all different domains? Who wants to leap in?
I'll take a leap of faith on this one. So basically, as a startup, there's two different ways that you can try to pay somebody. It can either be through a conventional salary, which assumes that you have some degree of funding in order to pay that salary, or you can pay people in terms of equity. Which is usually what most startups will end up doing while they don't have any funding in order to pay a salary. In either case, though, it really comes down to what's your network like and who are you able to connect with that way. If you don't have a salary, then you're not going to be able to attract the same kind of caliber of talent as someone that does have some degree of pre-seed funding. So that does present as a barrier. The way that we tried to mitigate it was by using wage subsidies and working with students because they tend to be a bit more cost effective. But the downside being that working with students tends to be a bit of a slower development progression compared to if you were just able to hire a full stack developer right off the gate. So that's definitely a barrier. Alberta Innovates is trying to do some good work as far as finding ways to alleviate some of those bottlenecks. So they've got a couple of grants and programs that are helpful on that end. But I'd be curious what the other panelists think on this one.
Yes. Dr. Trang.
Yeah, I totally agree with Ty. I think he covered everything. We had mentioned something about the pace. It is certainly a different pace when you meet with potential investors and what they expect, and they basically want things done like yesterday, which is hard for a small academic lab to do. And so at some point in time, we need to go for a proper raise, and then to separate sort of what's happening in the lab and what's specifically for the company with full-time employees. And so we're going through that transition. But certainly the pace and that pace is tied together with, and I mentioned in my talk, the importance of, people, right? Because we need to secure talent. We need to have the right expertise to be able to then move our technology forward.
Right. Do you want to take the last word on this?
Um, you know, it depends on what kind of talent you are looking for. Yeah, I mean, certainly from my experience, we have enough talent in certain areas, but not in others. But I would say that that would be the case everywhere, right? So we have enough. I think we need a better infrastructure to help move companies along in the province of Alberta.
Okay.
Yeah,
Well, sorry.
I was gonna say the one area within Alberta's ecosystem that is particularly lacking talent is kind of more for like senior roles. It's like senior software developers, people that have already some experience, like doing a startup and exiting. So there's now we've got our talent pipeline fleshed out where there's lots of early stage and entry positions, but not as much on the senior side, which is helps you go from establishing something to that next level, which is a little bit more where Trang and we sound like they're at.
Right. Okay. Well, thank you for that. And on that note, according to my schedule, we were supposed to end at 3:45. According to my computer, it is 3:45. It's been a very full day of content and contribution and insight and expertise. Thank you. A very close, quick, personal thank you to the folks behind the scenes. Adam and Craig are living in a computer somewhere. I just want to thank them for their expert guidance for me and for all the presenters. I want to thank all the presenters. Did an amazing job. It was a really great conversation. And I'll throw in a plug for the Gardner Foundation as well, who understands the importance of this sort of dialogue, this sort of conversation. And with that, I will turn it over to Dr. Robert Sutherland of the University of Lethbridge, who I think is going to bring us home.